Okay, listen. So there are mainly four types of reactions. What are those? Substitution reaction, substitution reaction, addition reactions, elimination reactions, and rearrangement reactions. So there are four types of reactions mainly in organic chemistry. So these substitution reactions are again further classified into free radical substitution, electrophilic substitution, and nucleophilic substitution. Okay, so substitution reactions are further classified into electrophilic, nucleophilic, and free radical. So addition reactions are also classified into three types: electrophilic addition, nucleophilic addition, and free radical addition. Right? Elimination reactions are classified into E1, E2, E1 CP reaction. E1 conjugate base, CP means. Okay, rearrangement there is no further classification. So many rearrangements are there, like Pinacol rearrangement, Wagner-Mervin rearrangement, okay, benzylic rearrangement. Like that, many rearrangement reactions are there. So that there is no classification. Now, in this again, nucleophilic substitution reactions are classified into three types. Nucleophilic substitution are further classified into three types: SN1, SN2, SNI. Unimolecular nucleophilic, bimolecular nucleophilic, and nucleophilic inversion. So these are the main types of reactions. So we will see one by one. So today maximum substitution I try to complete, so that it is in 3 days I have given for this. So accordingly with problems we will do. Fine. Even though it is sufficient or not, we have to adjust. 3 days is not too less and not too more. Fine. So first we will see what is a substitution reaction. Okay, clear? Everyone? Now, what is meant by substitution reaction? A reaction in which an atom or a group of atoms are substituted by another atom or a group. A reaction in which an atom or a group of atoms, an atom or a group of atoms of the substrate are substituted by another atom or group. Substituted by another atom or group. Then that reaction is called as substitution reaction. A reaction in which an atom or a group of atoms of the substrate are substituted by another atom or group, then that reaction is called as substitution reaction. Okay, means one atom in that an atom place, other atom will substitute, like chlorine place the bromine, like that. Or a group of atoms also. Sometimes OH group is substituted by Cl, like that. Okay. So based on the attacking reagent, these are classified as electrophilic substitution, nucleophilic, and free radical. So based on what? Based on the attacking reagent. Attacking reagents means I told you electrophiles, nucleophiles, and radicals. So based on the attacking reagent, these are classified as electrophilic, nucleophilic, and free radical substitutions. Okay. So if the initial attack is an electrophile, if the reaction is attacked, if the reactant is attacked by an electrophile, that type of reaction is called as electrophilic substitution, like that nucleophilic, and same as radical. So first we will see about electrophilic substitution reactions. So generally which type of compounds will give substitution reactions? Which type will give substitution reactions? Any idea? Alkanes, alkenes, alkynes, aromatic compounds, alkyl halides, carbonyl compounds, alcohols, ethers, phenol, all these are there now. Among them, which will undergo substitution reactions? Aromatic compounds, yes, still. Saturated compounds mainly undergo substitution, and unsaturated compounds mainly undergo addition. Understanding? Saturated compounds will undergo substitution, and unsaturated compounds undergo addition reaction. So we will see what is meant by electrophilic substitution. So generally saturated compounds undergo. So benzene is a saturated one or unsaturated one? Benzene is a saturated one. It has more saturation character. Though it is having double bond, it has saturating nature is more. Why? Because this double bond is not a true double bond, it is delocalized double bond. Actually C single bond C strength is how much? 1.54 angstrom. C double bond C is 1.34 angstrom, and C triple bond C is 1.20 angstrom. Whereas in benzene, the C double bond strength is 1.39 angstroms. Means it is less than single bond. It is between single and double bond, right? Less than single bond and more than double bond, right? So because of that, it has some saturation character. Means it does not give two tests which are given by unsaturated compounds. What are the two tests? Tell me. Bromine water test, another one Bayer's test. These are the two tests given by an unsaturated compound like KMnO4. Alkaline KMnO4 is called Bayer test. If a compound is unsaturated, they have to give these tests. Unsaturated compound should give these two tests. So, but benzene does not give these two tests. Okay? So that is why benzene is called as a which compound, children? Saturated compound. Okay? Means more character will be there. So as it is a saturated, so it undergoes what type of reactions? Substitution reaction. Benzene is a saturated, so it will undergo substitution. After that, this electron cloud is more in benzene nucleus because of the 3 double bonds. So as electron density is more, it will attack what? It will attack electrophile. Okay? So that is why, what are the characteristic reactions of aromatic compounds? Characteristic reactions of aromatic compounds are very, very important. Aromatic compounds are electrophilic substitution reactions. So these are the characteristic reactions. Other than that, addition also they will undergo. But what are the main reactions? Means electrophilic substitution reactions are the main reactions. So for every element, for every compound, you should know what type of reactions they will undergo. Suppose if I take alkene, alkenes will undergo what type of reactions? Mainly alkenes will undergo what type of reactions? No idea. Free radical substitution because the compound is saturated. Okay na? Next, alkenes will undergo what type of reactions? Main reactions I am talking about. Mainly, alkenes will undergo addition reactions mainly. Maybe electrophilic addition or radical addition. Next, carbonyl compounds will undergo what reactions? Mainly, carbonyl compounds main reactions. Nucleophilic addition. See, many people will confuse. Here nucleophilic you will write, but if you write substitution, it is wrong. Because it is unsaturated now. C double bond O is unsaturated, right? So it undergoes nucleophilic addition. So double bond is addition, like that. Alkynes will undergo what? If they are also having double bond, so mainly addition and some substitution because of the acetylenic hydrogen. Because of acetylenic hydrogen, it can be substituted. So like that, every compound you should know. Alcohols will undergo what type of reactions? Mainly, main reactions I am talking about. Nucleophilic substitution. Okay? OH can be substituted with other thing. Why substitution? Because alcohol is a saturated one. Understand? So like that, aromatic compounds will undergo what type of reactions? Electrophilic substitution reactions. Main things. H and all are there. Electrophilic substitution. Aromatic compounds. Okay. Now we will see what are the electrophilic substitution reactions of benzene. Mainly, I won't teach mechanism because it will be time taking process. But for one thing I will tell, remaining all will be same. Okay children, so we will see the electrophilic substitution reactions of benzene. So what are the electrophilic substitution reactions of benzene? Yes. Electrophilic substitutions of benzene. Tell. What's your name? Vinay. Niranjan. Okay. Tell some examples of this. Electrophilic substitution reactions of benzene. You have seen in the first year. Sulfonation, nitration, very good. Chlorination, right? Chlorination, nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. Those are the main. Other named reactions also there, like Gattermann reaction, Gattermann-Koch reaction. These are. So mainly, what are the things, children? Nitration first. Nitration, halogenation or simply chlorination. Chlorination or halogenation. Next, sulfonation. Next, Friedel-Crafts alkylation and Friedel-Crafts acylation. Friedel-Crafts alkylation and Friedel-Crafts acylation. So these are the electrophilic substitution reactions of benzene. Nitration, chlorination, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. So what are the reagents used in this process? Reagents. Nitration, what we use, children? Nitration mixture. What is nitration mixture? Concentrated nitric acid and concentrated sulfuric acid in 1:3 ratio is called as nitration mixture. And chlorination, what you use, children? Chlorine in the presence of Lewis acid like AlCl3 or FeCl3, like that. So this is the reagent used in this. And sulfonation, what you use? Fuming sulfuric acid. Means H2SO4 plus SO3 you can add, or oleum you can say, H2S2O7. H2SO7 or this one. And Friedel-Crafts alkylation, what you will use, children? Alkyl halide in the presence of Lewis acid AlCl3 or FeCl3. Alkyl halide. So example, if you add methyl chloride, then it is called as methylation. Friedel-Crafts methylation. If you add ethyl chloride, Friedel-Crafts methylation. So Friedel-Crafts acylation, what you will use? Acyl chloride. This is alkyl chloride. This is acyl chloride. Acyl, ACYL. If R place you keep CH3, then that is called acetyl chloride. What is this? Acetyl. So Friedel-Crafts acetylation or acylation. Small difference. Acyl means RCO. Acetyl means CH3CO. R place if you keep CH3, that is your acetyl. So these are the reagents used in the process: nitration, chlorination, sulfonation, and Friedel-Crafts alkylation and acylation. Understanding? Now, what is an electrophile in this? What is an electrophile in the nitration? Yes? Last second. Tell them. What is the electrophile in nitration? Yun. Advita, I forgot. Your name? Sure. Okay. What is the electrophile in this? Nitration, what is the electrophile? Just electrophile name. No idea? No problem. Second bench. What is the electrophile? NO2 plus. Okay. Nitronium ion. See, what is this? Nitronium ion. Onium means positive charge. Carbonium, carbon bearing a positive charge. Nitronium, nitrogen bearing a positive charge. Onium means positive charge. Benzene diazonium chloride, BDC, means what? Benzene ring. Chemistry, every word if you spell properly, the meaning is there itself. Benzene, di means two. Aza means what? Nitrogen. Onium means what? Positive charge. Chloride. This is called BDC, benzene diazonium chloride. You have seen? Second year already over or not? Amines chapter over? Amines chapter. So BDC, benzene diazonium chloride. Like that. Hydronium ion, H3O plus. Ammonium, NH4 plus. Right? Like that, nitronium ion is the electrophile here. And here what is the electrophile? Cl plus or X plus. And here what is the electrophile? I told you? SO3. This I told you now. It is a neutral electrophile here. Now, Friedel-Crafts alkylation, what is the electrophile, children? R plus. And acylation, what is the electrophile? RCO plus. Alkyl carbocation and acyl carbocation are the electrophiles in this. Fine. Now, what are the products formed here? One more point I told you. Among all the reactions, only sulfonation is reversible. Sulfonation is reversible. This I told you. Remaining all are irreversible. One time they asked in previous competitive examination. Among electrophilic reactions, what is reversible reaction? Sulfonation. Yeah. Now what are the products formed here? If you do nitration, what will be product, ma? For benzene, if you do this nitration, this is all if you do for benzene. For benzene, if you do all these reactions, tell me the product. Here you will get nitrobenzene. Nitrobenzene is the product formed here. Okay? Understanding? Next. Here what is the product? Chlorobenzene. So benzene on chlorination forms chlorobenzene. Here sulfobenzene not benzene sulfonic acid. What is the product here? Benzene sulfonic acid. So benzene nitration, nitrobenzene, chlorination, chlorobenzene, but sulfonation, benzene sulfonic acid. Whereas Friedel-Crafts alkylation, you will get alkyl benzene, and acylation you will get acyl benzene. This is alkyl benzene, and this is acyl benzene. Instead of R, if you keep CH3, then it is acetyl benzene. Instead of R, if you keep CH3, that is your what? Acetyl benzene. Then what is the other name for acetyl benzene, children? Acetophenone. What is the other name for acetyl benzene? Acetophenone. Have you remembered? What is the difference between acetophenone and benzophenone? Yesterday I told. Who will tell the answer? Those are very good. They are listening properly in the class. What is the difference between acetophenone and benzophenone? Once I told this. Acetophenone and benzophenone में फर्क क्या है? Difference क्या है? What is the difference between them? No idea? Forgot? What, children? One will undergo tautomerism, other won't. Okay. But examination point of view I want. Means suppose if they are given in the board for 1 mark, what will you do? How will you distinguish means you can tell. If even that point is added, you can tell that answer is right. Means in MCQ you can write multiple choice question. This carbon is more electrophilic. Iodoform test. Did I tell or not? Methyl ketone is a test for iodoform. What is iodoform? Yellow color CHI3. Chloroform CHCl3. So iodoform test is very important test in your competitive exam. Understanding? So acetophenone will give the iodoform test. Benzophenone does not give because of absence of methyl ketone group in benzophenone. So methyl ketone group is the necessary condition for an iodoform test. So here there is methyl ketone, but here not there. We will study more about it later. Okay? In further reactions, carbonyl compounds, I will tell you. For 10 to 15 minutes, we can talk about iodoform reaction, which is very important for the competitive exam. Fine? Next time you have to say, understood, ma? Can you able to see this? Acetophenone give positive iodoform test. Benzophenone does not give iodoform test. Easy to remember. 2 benzene rings benzophenone, 1 benzene ring acetophenone. So benzene, how to prepare acetophenone? Benzene on reaction with acetyl chloride gives acetophenone. It is what type of reaction? It is what type of reaction? Benzene to acetophenone is what type of reaction? Which reactions you are studying? Electrophilic substitution reaction. You have to say like that. Okay? So they will ask, simple bits are like that only. Preparation of benzene to methyl benzene is an example of electrophilic addition, electrophilic substitution, free radical addition, free radical substitution. What is that? You should know it is electrophilic substitution. Understand? Shall I erase, children? Is it clear? Now, so one mechanism I will tell you, easy only. Remaining all will be in the same manner. Understood the questions, how to study also. See, electrophiles they will ask, so that this tabular form will be useful. Now, one mechanism. Every electrophilic substitution reaction takes place in 3 steps. Step 1 is generation of electrophile. Generation of electrophile. Step 2 is formation of a carbocation. Formation of sigma complex, you can say, or else aryl carbonium ion. Aryl carbonium ion. ARYL, aryl carbonium ion will be formed. And third step is formation of product. Third step is formation of product. Only for one thing I will teach. Okay. Remaining all little similar. Second step, only this electrophile generation will be different. Understood? So, how will you generate electrophile here? I am talking about nitration mechanism. Mechanism also sometimes important. Why? Because previous exams they asked what is the intermediate in Remer-Timmer reaction. Remer-Timmer reaction, what is the intermediate? Dichlorocarbene, CCl2. Carbene is an intermediate. What is the intermediate in aldol reaction? Carbanion. What is an intermediate in Kenizaro reaction? Or in Kenizaro reaction, what is the slow step? Kenizaro reaction, what is the slow step? Hydride ion migration is the slow step. Kenizaro law. So that mechanism you should know. So what is slow step? Rate determination step. The reaction may take place in several steps, but one step is the slowest among them. That is called rate determination step. Kenizaro reaction, these are all previous questions only, previous competitive exams. So what is the slowest step in Kenizaro reaction? Hydride ion migration, H minus shift. That is the slowest step. So for sometimes mechanism also needed. Okay, don't think that this is board, the Y2 mechanism for MCQs. Concept also involved in that. Okay, so generation of electrophile, first what you will do? This is nitric acid, children, HNO3. This nitric acid will take the H plus given from sulfuric acid, because nitration you will add these two. So this O will take the H plus and it will form NO2 OH2 plus. This is called protonated nitric acid. Protonated nitric acid. So everyone knows what is nitric acid? HNO2, HNO3, nitric acid. So nitric acid, if it takes proton, it forms protonated nitric acid. Now, this protonated nitric acid, what it will do? It loses water molecule to form NO2 plus, which is our electrophile. This is our electrophile. Plus H2O. That's it, over. Okay? So this will get cancelled if you add. So this is how you generate the electrophile. So this is the first step in every reaction. Generation of the electrophile. Now second. Generation of the electrophile. So after generating electrophile NO2 plus, so how will you do? So this bond will migrate like this, electrophilic part. So benzene ring, you will get here NO2, and remaining bonds will be like that, but this is plus charge. So this is called formation of aryl carbonium ion. See, whenever I am migrating a bond, what I told, here you will get a negative charge, head is negative, tail is positive. That negative charge and NO2 will form a bond, and positive charge will remain in the as it is. Understand? So you know this resonance forms now. So this bond again will migrate like this. So that result you have to show here means this will be a double bond and you will get a positive charge here. So first you show the migration and then positive charge will be here. You will get a double bond here. That's all. From this you have to write this step. Next, whatever bonds are there, as it is you write like that. As it is. Now one more resonating form. This will be like this. So here there is a double bond. Here there is a double bond like this, left side. And remaining bonds are as it is. Okay. So positive charge will form it. So these are the resonating forms. So you can simply write these all forms as resonating hybrid. What is that form? Like benzene, NO2. Where NO2 is there? Here you put the symbol like this. Means what is that? Electrons are revolving in this all carbon delocalization. That is called resonance hybrid. This is the more stable form of all these things. Okay? Resonance hybrid. Understanding mechanism?